Hello everyone, welcome back to my YouTube channel. As you all know that this is Soumya Reddy S, currently studying at Sri Venkateshwara College of Engineering, Bangalore. Today I am here to discuss about the topic as shown in the screen, functional dependencies and normal forms from the subject database management system. Let's see the introduction to functional dependencies. Functional dependencies describe the relationship between attributes in a relational database. It exists when one attribute determines the value of another attribute. These are represented using arrow notation, where the determining attribute is on the left and the determined attribute is on the right. Example of functional dependencies. Let's take an example of student database. In student database, we need the student ID, name, major, etc. In a student database, the attribute student's ID determines the attribute student name and student major. This can be represented as seen in this screen. Functional dependencies help ensure data integrity and reduce redundancy in the database. Primary keys and normalization. Primary keys are unique identifiers of a record in a table. Normalization is the process of organizing data in a database to eliminate redundancy and improve efficiency. Normalization is based on the concept of functional dependencies and use different normal forms. Here we can see the table in that there are four columns: student ID, first name, last name and course ID. And the student ID is primary key. Each and every student has their own ID, so it is known as primary key. Let's discuss about the normal forms in the database management system. There are three types of normal forms: first normal form, second normal form and the third normal form. We'll discuss about them with examples. First normal form. First normal form ensures that each attribute in a table contains only atomic values. Atomic values cannot be further divided. First normal form eliminates repeating groups and ensures each attribute as a single value. Let's see first normal form. The domain of an attribute must include only one atomic values and that the value of an attribute shown in tuple be a single value from the domain of the attribute. Here a tuple is also known as record or a row. It's a basic unit of data in a relation database management system. A tuple represents a single instance of a relation or a table in the database. Each tuple contains a set of values or attributes that correspond to the columns or fields of the relation. Let's take the example of the department. In department, we need department name, department number, department manager SSN number, and the department locations. So we know first normal form we need the atomic values. So let's segregate the D name, D number, and the D manager SSN as shown in the table. Second normal form. Second normal form builds upon first normal form and further eliminates redundancy. Second normal forms requires that all non-key attributes are fully dependent on the primary key. If an attribute depends on only part of the primary key, it should be moved to a separate table. Note that a relation that is in first normal form and every non-primary key attribute is fully functionally dependent on the primary key. Then the relation is in second normal form. Note that if the proper subset of the candidate key determine a non-prime attribute, it is called partial dependency. The normalization of first normal form relations to second normal form involves the removal of partial dependencies. If a partial dependency exists, we remove the partial dependent attributes from the relation by placing them in a new relation. Example of second normal form. In a product database, the primary key is product ID and the attributes are product name, category ID and category name. The attribute category name is dependent on category ID, which is part of the primary key. To achieve second normal form, category name should be moved to a separate table along with category ID. Here in the table we can see employee table. Here employee number, employee last name and the department number. To separate the primary key, we'll remove the department number and we'll separate it in two tables, employee table and employee department table. In employee table, we have employee number and employee last name, and employee department table, we have employee number and the department number. Third normal form. Third normal form eliminates transitive dependencies between attributes. Transitive dependencies occur when an attribute depends on other attribute that is not part of the primary key. Third normal form requires that all non-key attributes depend only on the primary key. For example, two examples of functional dependencies: order and shipment. Order ID, quantity, price and total. In shipment we have ID, provider, weight, per LB and cost. By segregating these two, we get the non-key attributes in the third normal form. Example of third normal form. In an employee database, the primary key is employee ID and the attributes are employee name, department ID and department location. The attribute department location is dependent on department ID, which is not part of the primary key. To achieve third normal form, department location should be moved to separate table along with department ID. Here in the table we can observe employee table, employee number, employee last name and the department number is segregated in two tables, employee table and employee department table, and employee number and employee last name is moved to the employee number and to the department number. Benefits of normalization. Normalization helps reduce data redundancy and inconsistency. It improves database performance by reducing the amount of data duplication. Normalization also simplifies data maintenance and updates. Some of the challenges of normalization. Normalization can lead to an increased number of tables in the database. Complex queries may require joining multiple tables, which can impact performance. Finding the right balance between normalization and denormalization is crucial for optimal database design. Conclusion. Functional dependencies are important in determining the relationship between attributes in a database. Normalization based on primary keys helps eliminate redundancy and improve data integrity. Second and third normal forms provide guidelines for organizing data in a relational database. By this, I'll end my session. Thank you.